બોલવું પડશે યાર, આ તો બધું ડિફિકલ્ટ થઈ જશે. એકચ્યુઅલી અન્ના હજારેને આટલી તકલીફ નથી પડી યાર. રાઈટ, ઓકે. હાઉ મચ structural fundamentals are clear with you? I don't know. Actually, what I want that your basic fundamental knowledge related to the structure analysis, that is most important, because say softwares nowadays are available so often, different types of softwares, not only the structure analysis, it is also related to the designs. Designs, quantitative analysis, abstracts, labeling, contour works, for everything softwares, ready-made softwares are available. Now it is up to you how frequently you use that one. We don't mind that you use the structure design analysis software, but basically once you use that, let us say if you have prepared one particular structure into the software, fundamentally you must be able to resolve that one. You must be able to think that okay, this type of loading is there and the results are shown in some different way. Is it right or wrong? That means interpretation of the result is very important. We will see that one over here. Your structure axis, member axis, local axis, all these parameters are also required. So probably you might have come across with the stiffness method, right? Again, stiffness method, then finite element method, both these methods are included into this particular software. So let us see that one. Now yesterday this program was started, right? And how much depth you have cleared into this one?
Design
Design,
frame, design of frame, beam, column, design
continuous beams over
continuous beam નથી બતાવ્યું અને પછી બતાવ્યું continuous beam બાકી છે.
Okay, then frames you have generated, right?
Yes.
So today nearly about 1 hour and 30 minutes, maybe 1 hour 45 minutes. My idea is how to use the STAAD, especially for the space frame. Space frames be specific for the RCC work. Let us introduce the slabs into this one, apply some member loads. On the slab, apply some loads, uniformly distributed loads. You might have calculated the designs of the slab, right? Normally we find that one way and two way slabs, one way continuous, one way simply supported, and the two way slabs. And we know that once we apply the load on the slab, they are transferred to the beams in a particular way only. If it is a one way, QLX by 2 on either side. If it is a two way, then QLX by 3 and QLX by 2 into 1 minus 1 upon 3 times beta square. These are the simple formulas, and according to that, from two-way slab, trapezoidal loading and triangular loading, you can transfer onto the beam. The same things will be over here. So in this particular first problem, let us see that one. In this problem, a space frame has been generated. Now you know that how to generate the space frames, right? You go to the structure wizard, open the frames, and into the frames give the global x direction dimensions, y directions and z directions, as well as the panel dimensions too, and paste that particular model into your main frame. So this is the one problem. Now here, if you see that one, just for the explanation only, I am clicking the load numbers. Let us say these are the node numbers over here. One is on this one, two, right? Like this way, all these are the node numbers. Again, I am giving some other things, the beam numbers. So at any stage, if you want to see, these are the some numbers. I am removing the beam numbers, now applying for the plate numbers. Okay, so you can see that at the ground floor slab level, plates are being introduced: 85, 86, 87, 88, 89, then 90, 91, 92, 93 and 94 at the first floor slab level. At the plinth level, no plates are being provided, only the beams are provided. So that you can see it over here. This is the simple beam. As far as the dimension is concerned, all these dimensions are 3 meter each. 3 meter each. In Z direction, dimension is 8 meter. Plane height is 1.2 meter. Then floor to floor height is 4 meter. So this is the simple frame, space frame, very typical space frame is over here. Any input file now? Text file असेल editor file.
मिनिमाइज करो, डबल क्लिक करो.
Yes, this one. So now the joint coordinates. These are the joint coordinates. So you can just later on you can edit this one, but this is how you have to interpret that the node number 2. It starts from the, and coordinates are x is the 3, y is 0, z is 0. So immediately you can see that in the x direction, if you move 3 meter dimensions, y and z keeping 0, that's the lowermost coordinate is that, right? So these are the joint or the node coordinates. Member incidences, this one. This member incidences is, it is like this way, that this member starts from this particular end or this particular node, and it ends at this particular node. So everything is being written over here. Let us say member number 20, it starts from the 5 node and ends at 11. Is it okay? Thereafter, element incidences cells are being implemented. So this particular cell, see 85, plate number 85, it's a quadrilateral element. So 85, node 13 14, 38 and 37 are connected with that one. Same way, plate number 86, 14, 15, 39, 38. So like that way, some plates are being added. Now this one you can do it over here. Let us say, as for example, I am adding one of the plate. So for that one, you go to the geometry, add plate, I am using another version. એમાં સીધું લખવું પડશે. આ બંધ કર દો. ઓકે. So to add the plate at any circumference, you have quadrilateral and triangular plate. So I have selected quadrilateral, selecting the node. So another plate is being added, that is plate number 95. Again, this particular plate 95, 96. So this is how you have to add the plate. It is not like that way that in XZ plane only you can put it. Suppose if you want to add one of the plate over here, that you can do it. So this particular plate, 97 number plate, is in YZ plane. Vertical. At any stage, suppose if you want to add it, because this is a very small problem, but if you want to edit any particular member specifically, that you can do. ये बताई दी तुझ use generate कराएंगे. ठीक है. Let us say I want to work over the planes, so select that one, right click the mouse, new view, create a new view. Okay, now it's 3D. Plate cursor you have to provide. No plates over here. Right. If you want to go back, whole structure, click that one. Now I am removing this one because at present it is not so required for me. Plate number 97, 95, 96. So I am going to the editor. Removing that one. Okay. So this is how you have to input the plates. At the maximum, sir. Now the loading. Supports you can give it, no problem. So commands. Loading. Loading ની અંદર primary load છે. Primary load pick up કરો તમે. I am closing this one. And while going through the editor, showing that one. See, the element property is being given. So 85 to 94, all these plates are of 0.15 thickness. Supports 1 to 6, 25 to 30 are fixed. Load case 1 is the dead load. Member load, this one is understood. Member number 1 to 15, as well as 34 to 48, 67 to 84, all are subjected to some UDL, gravitational loads, 20 kilonewton per meter. This is member loads only, that you know. This is important now. Load case 2, specifically it is being generated. It is from the slab, because my basic idea is to how to transfer the load from slab to the beam, right? So load case 2, load from the slab, area load 73 to 84, A load minus 10. What I mean to say, that on the plate 10 kilonewton per meter square total load, or it may be a factor design load, is being applied. 10 kilonewton per meter square minus, that is, it is negative to the y. Y is vertically positive up, okay? So it is minus, so it is acting downward, but it is acting on the plate. Now it is the area load. Basically, there are two types of the loads in the STAAD. One is the area load and another one is the floor load. Both are different. Both are different. Area load, if you know the configuration of the plate, in this particular problem, all the plates that you can see, they are one way distribution. So whenever you want to transfer the load from one way slab to the adjoining beam, in that case you have to go for the area load. But if the slab is in two-way form, suppose the plate dimensions are 3 meter by 4 meter, naturally Ly by Lx ratio is less than 2. So in that case, you go for the floor load. Here, in this particular problem, area load is being taken. So 73 to 84, A load minus 10. 73 to 84, they are not the plate number, they are the member numbers. They are the beams only. Thereafter, load combination is performed. Dead load plus slab load. First load case, safety factor is 1.0. Second load case, again you combine that one with the one and the safety factor is 1. Thereafter perform analysis, print all, print member forces. Later on I am going to take the concrete design. See, this particular facility is over here. Dead load, live load, and these three load cases you have defined. First is the dead load. That is the uniformly distributed load. That you can see it over here. Let us say load values print, apply. So you can see that all the members, beam members, are subjected to the 20 kilonewton per meter UDL. Is it okay? Second load case, it is from the slab. If I click it over here, it doesn't show any load. Area load would not be over here at present because it is being just generated. Once you go for the analysis, after completing that particular analysis, you would be able to see this particular load, right? So what we have given, it is 10 kilonewton per meter square. This particular dimension is, let us say, 3 meter. So 10 into 3, 30 divided by 2, QLX by 2. So 15 kilonewton per meter load would be over this beam or this particular beam, or in this beam 2 times from 90 and 91 plates. On this beam 2 times from plate number 85 and plate number 86. So let us go for the analysis. Run analysis. Stay in modeling mode. Okay. Now you can see that load from the slab, second load case is being on now. On this particular beam, now the load from the plate number 85, it is minus 15 kilonewton per meter. On this particular, it is 30 kilonewton per meter. So straight away, the slab loads are transferred in one-way distribution form. Is it okay? Now thereafter, start concrete design. See, these are the steps that you have to make it. Start concrete design. Code obviously IS 456 FC 20,000 kilonewton per meter square. That's the unit. It's a M20 grade of concrete. And member 1 to 94, all the members are of M20 grade. The main reinforcement to resist the flexural F5 main FE415. Then secondary reinforcement, it is being written 2 times over here. So let us delete this one, no problem. Secondary reinforcement FE250. You are suggesting that you can use the main reinforcement up to 20 mm diameter in all the sections. Secondary, still maximum diameter is 10 mm. Main reinforcement, if the area is very less, you can use 10 mm diameter as a minimum diameter. Then secondary reinforcement 8 mm diameter. All the forces that would be multiplied by 1 only. Normally you find that while working with the working load, in the limit state you have to multiply that particular moment with the 1.5. That is the partial safety factor. So that is up to you, that whether you have applied the loads on the structure as a limit state load or the working load. If it is a working load, then while design, all the member forces should be multiplied with the 1.5. Here I have taken it is equal to 1. Design element 85 to 94, design beam, design columns, concrete tape-off command is being applied, so you can find a quantitative analysis too. Now, before we see the design details, actually let me speak that these are the softwares only, and as a designer or as a STAAD utilizer, you have to see that whether this particular design, how to operate it. Because let us see that the design details, these are very awkward details over here. So these are the member forces. So beam number 3, design results, right? M20, FE415, FE250 secondary. Length is 3 meter. Size of the beam is 230 by 450. Cover, that is 25 mm. Top reinforcement 197.38 mm square. Bottom reinforcement, something is being given. So STAAD suggests that to provide two numbers 12 mm diameter in one layer at the top of the beam, and at the bottom two numbers 12 mm diameter. And this is the details about the stirrups. Two leg 8 mm diameter, 230 mm center to center. Now once you see that one, this is the concrete takeoff command, right? For beams, columns and plates designed above, concrete quantity represents volume of concrete in beams, columns and plates, reinforcing steel, everything. So these are the different diameters of the bars which are used in the design, and the weight required, it is this much, and 28.92 ton steel is required in 47.1 cubic meter of concrete. If you are so interested, then you can pick up this one, otherwise so. So post processing mode. But let us see this post processing part. I am taking this particular part. Right click that one, new view. Okay. It's a bending moment diagram. Click that one, shear force diagram for all the beams. With way, this is a longer beam. If you want to see the values, go to the result, view values, shear, if you want to see the result element wise, it's okay. Completely whole structure, three-dimensional view. And this one, let's say Actually, double clicking that particular member, property is okay. This is the geometry. Property is simple. Loading, shear bending. Now you can see over here that at the support 42.34 kilonewton meter bending moment is there, and this particular creating tension at the bottom, it is 117.66. Don't confuse that if manually if you are designing this one, normally our sign conventions are slightly different. We consider that as per IS 456, we consider that the tension moment which creates tension at the bottom is a positive bending moment, and the moment which creates tension at the top, it's a negative. But here it is slightly reverse. So 42.34, 117.36, and at some distances along the length of the beam, you can find out different shear force and the different bending moments. This may be useful for the curtailment of the reinforcement, right? This is a particular beam shear force diagram, deflection, concrete design, everything is over here. Stopping MZ, plate. Results, stress contours, MX, local. So this is related to the plate. So inside the slab, MX variations would be like this way. Now you have to interpret it properly, right? 0.27 local unit is being given, kilonewton into meter per meter. These are the values. Even on the side too, different parameters, SQS, XQY, SX, all these things are given. This is related to the bending moment MY direction, MX direction. So important thing that in the one-way continuous slab, you have to apply the loads on the plate using a load. Right? All these other things are so simple, but think about that. Now close it, file, open. Not the same problem, right? Now you can see that dimensions are different, but forming two-way action. Screen display. So you can see that in the X directions, complete structure you have to assume that it is over here. Complete structure at this particular point, right? Thereafter, X positive, this one. So 3.5 meter distances are there. Along the Z in negative direction, sorry, negative directions, 4 meter and 4 meter. Height of the structure 1.2 meter, 4 meter, and again the 4 meter. Let us see this straight away. The input 5 units are in meter kilonewton. Joint coordinates. As usual in the last problem too, different joints with the x, y, z coordinates are being given. Member incidences, that is all the members are connected from J end and K end. Element incidences are different elements are being added. These are the elements. Defined material start, isotropic concrete materials, member property, depth, width of all the members, element property, all the elements are 0.12 meter thick. Supports, all fixed. Load case 1 is dead load, that is the member load. Member numbers 1 to 12, 28 to so and so. Minus 20 kilonewton per meter is the UDL. Now say this particular part is important. Load case 2, that is from the slab. What I have written, now it is a floor slab. This is a floor load, because I know that plate dimensions are 3 meter by 4.5 meter. Now it is not a one way, it is two way. So I have to direct the software that whatever may be the plate load, you have to transfer it to the adjoining beams in the two-way pattern. So for that one, floor load, Y range, let us see the interpretation of this one. Y range 1.2 to 5.2. What is that 1.2 to 5.2? 1.2 is the plane height, right? Then next floor slab will be at 5.2 meter, like a 4 meter is the height of the floor. So 1.2 plus 4, that is 5.2. So 1.2 to 5.2, all the elements having the floor load of 10 kilonewton per meter square. X range is 0 to 14. So the elements which are in the range from 0 meter to 14 meter in the x direction, and all the elements 0 to 8 meters would be subjected to this particular load 10 kilonewton per meter square. Let us see that one over here. X range. See, the plates are over here. All these are plates, right? So as per that, very first one, very first line, this one, this element, or even this particular element, or this one, or this one. X range I have given from this point to this point. Y is obviously 1.2 to 5.2, right? So at this particular height, X range is this one, Z range is this one, and into that range, that means that this particular area, all the elements would be subjected to load of 10 kilonewton per meter square. If you want to say this one, this you can see, right? Even see this particular plate number 113, right? This one. Whatever may be load on this particular plate, shorter dimension is this one. So QLX by 3, it's a triangular loading is over here. QLX by. Why? This is 4 meter height, right? So this is a longer diameter, and you can see that the trapezium loading is there. Let me remove that door. Now you can very clearly see this, right? It's a trapezium loading. On this one is a shorter side. It's a triangle, then trapezium, triangular loading. Structure. So now you can see that it's a trapezium loading, right? This one. Other things are simple now. View again the full structure. Then if you see that input, load case 2 from the slab. Specifically, two different floor loads are being given. So next line is Y range 9.2 to 9.2. That means at the topmost floors, terrace level, 9.2 meter to 9.2 meter. Again, the floor load is slightly different. It is 8 kilonewton per meter square. In the next line, X range is again 0 to 14, and Z range is 0 to 8. Thereafter, load combination has been performed. Other things remain same, and the concrete design. So specifically, let us say I am taking one problem very fast, so you can see that how speedily you can generate the building space. Meters, kilonewtons. Next, open structure wizard. Finish that one. Cross models. So pick up the frame models, bay frames. Let us say length is 8 meter, height is 6 meter, and width is 3 meter. Along the length, what's 1 bay? Along the height, 2 bays. Along the width, 1. Apply that one. Edit, paste, and so. Is it okay? No? Thereafter, commands, member property, prismatic, rectangle, 0.75, depth 0.23 is the width. Add that one. Close. For the simplicity, I am taking all the dimensions same. geometry, add plate, so once the plates is being formed, go to the command plate thickness that you have to give it, let us say 150 mm thickness of the plate, material is concrete, add it, close, select that one. So for that, pick up the plate cursor, select this one, and this assign, yes, and close it. Is it okay? So as soon as you do these things, input file is ready with you. Next thing is the commands, support, fixed, edit, select that one, and using the node cursor, select the nodes. Yes, and close. How much dimension that we have given over here? Let us see that one. Dimensions to view, display, meter, close it. Now, these things normal happens to you that you need to change the building as and when required. Sometimes it happens that architect provides the drawings like this way. Thereafter, once you analyze and design, you find that architect says that, okay sir, we want to provide 2 more columns over here. Now, so editing is also an important part. So what we have to do, you have to insert the nodes somewhere over here. Let us say in this particular beam, in this beam, this particular 4 beams, I want to insert the nodes. So what I have to do, geometry, insert the node in this particular, at midpoint, okay done.
फरीથી insert કરો બરાબર કરો
geometry insert, taking this particular member, beam length 1 meter. Create figure. Delete कर दिया. Cut it. Geometry add beam from point to point. This one to this one. Geometry. Insert node. શું થયું? ખબર આનો બીમ નંબર્સ જોઈ લઈએ આપણે. Node numbers, beam numbers mention, right? Apply. So node number 13 is being added over here. Okay. Midpoint over here. So node number 14 is that. In this particular beam, again at midpoint. Okay. At midpoint. Okay. So plates are over here. I am deleting that one now. These plates I am removing. Element incidences, all these things I am removing. Save it. So these are the now two different beams, right? Once the nodes are being added, these are the two different beams. Let us say add the plate over here now. Geometry, add plate. Again, next plate is over here. Another plate. Thereafter another. Now, as soon as you change these things, you have to give the properties again. See that. So commands, plate thickness, yes, I am giving only one. Edit, close that one. Plate cursor. Assign, yes. Now you can see that this beams has been edited. So all these members are being assigned, but this particular member and this member too. This one will assign. I think you need one beam over here. So I am going to the geometry. Beam from this point to this point. Then the commands, member property, prismatic, cancel this one. So now everything has been given except the loads. So plate number 24, 25, 26, 27. Let us see that input. They are being defined over here. Along with the thickness, all the properties, everything. Commands loading primarily. I am taking simple load case from slab. This one is especially required. As a structure designer, sometimes we don't follow the IS 456 very strictly. Let us say in a particular residential building, even myself or sometimes Sumant is one of my friend. We give the design sometimes by ignoring just IS 456 simply. Let us the slab dimensions are 3 meter by 4 meter. We don't want to provide some beams on some other sides. So even though if it is a two-way slab, we design it as a one-way slab and we transfer the loads to the adjoining beams. More or less now often we do that one. Now if we want to perform the same type of analysis into the STAAD, you can do it over here too. Floor loads, pressure, -10, wide range. I think we have taken 4 meter. X range. Let us see the dimensions first. Forgotten that. 4 meter and 4 meter in X directions, 3 meter in Y directions, and 3 meter in this directions to right, Z direction 3 meter, X direction 8 meter. Loading. Floor loads. -10. Let us say this particular 6 meter because check the dimensions is 0, 8, 3. See, this option is available now, right? One-way distribution. Click that one. If you don't do this one, loading would be transferred from two-way slab. So specifically, I am saying that make it one-way distribution.
ऐड करूँ सर?
हाँ ऐड करूँ कुछ
एंटर
नीचे देखा तो नहीं देखा एंटर कर दो
एंटर
So 4 meter by 3 meter panel is there. Let us say this particular panel. Taking this one. This dimension is 4 meter. This dimension is 3 meter. So as per this, it should be a two-way slab, but you can see that now it is being distributed. The loads has been distributed to one way, right? So inside of the floor load, if you have the option whether you want to transfer it as strictly as per the two-way or one way. If you keep it as one way, but the problem that you just check up that one, suppose the 4 meter by 4 meter panel is there, and if you apply the load, let us say 10 kilonewton per meter square, give one way distribution into the floor load, see what happens. Because now STAAD is not knowing that in which direction you want to transfer the load. So 10 into 4 divided by 2, 20 kilonewton per meter load would be applied on all the 4 wheels. So naturally, it creates a problem for the software because it doesn't know that in which direction you want the one-way distribution, right? Here it is okay, along the longer side, software has transferred the loads. But if it is a strictly 4 meter by 4 meter or 3 meter by 3 meter panel, then it creates a problem. Now, slightly see one more problem. ના મારે આ નથી જોઈતી હવે. So element is being, in this particular problem, element is being provided vertically. It acts as a shear wall. Frame is simple. The loads you can see, dead load plus live load. Joint coordinate, member incidences, elements 12, 13 and 14. 3 elements are being provided. Element properties, thickness is 0.15, supports are being given. First, this name is being given for the lateral loads, wind load. It may not be exactly that one, but the joint loads are being given in z direction at nodal 4, 12 and 8, minus 9 kilonewton and minus 20 kilonewton. So these horizontal loads are being given on the frame. Then another load case is the dead load plus live load. So floor loads are being introduced with the Y range 4.5 meter to 4.5 meter, 10 kilonewton per meter square, 0 to 12, 0 to 6. And then load combination has been performed and the design. Maximum sizes are here. Floor loads distribution, wind loads. This is 9 kilonewton, very small line, somewhat big arrow, 20 kilonewton, and 9 kilonewton. If you want to see the values, you can see load values, apply. So 9, 9 and 20 in the z direction. If you go for the analysis, mode, post processing, results, stress control, normal, MX, and apply. So stresses in the shear wall would be like this. Okay, and these are the stresses in the slabs. So this is for the load combination. If you want to remove that, then make it none, apply, okay. Complete bending moment diagram and the shear force diagram, maybe for any dead load case. So you can introduce the plate element over here as a shear wall and then design it. Simple plates problem, water tank. Rectangular water tank 6 meter by 6 meter, 1.5 meter plates. So see this plate 45, right? Let us say this particular plate X, Y and Z coordinates. Dimensions are 1.5 meter each. Properties of concrete is being given. Loading આપેલું છે આપણે અહીંયા આગળ પ્રેશરના ફોર્મમાં આપ્યું છે અહીંયા આગળ. So loads, pressure has been given. Naturally it's a water tank, so maximum pressure would be at the bottom, thereafter some less and so on. If you analyze this one, only one load case is that results. At the base, stress controls are over here. If you go to the results, plate stress control, okay. Units are being written, okay. MX local, kilonewton meter per meter. And stresses are 15.9 at the center of the wall. That's the maximum one. So it is somewhere over here in this joint. Some stresses are minus. See this one. These are positive. But anyway, you have to interpret it properly. So okay, I am stopping over here now. Friends, plates ને એની કંઈક અંદર કંઈક તકલીફ હોય તો મને કહો તમે. Otherwise you do the exercise for that one. તમારી પાસે વિશાલ સાહેબ છે, so he will guide you.
Everybody needs to attend that, and you have to go into auditorium hall, okay, where your attendance has been taken. being a member who is present over there. Naturalization committee is waiting for it.
કેટલા વાગ્યા કે
3 વાગે.
હે
3 ને 10. હા, અહીંયા આવજો. લેબમાં જવું છે કે અહીંયા લેક્ચર તમે સાહેબ નીકળો છો?
ના હવે સુમંત મળશે ને મને
એમને 2 વાર ફોન કર્યા, હજુ ઉઠાય નહીં. જમવા નતા એટલે
છોકરાઓની જરૂર છે મારી થોડીક વાર માટે
અત્યારે તો એ લોકો ઓડિટોરિયમ
કમ્પલસરી ઓડિટોરિયમમાં જવાનું
શા માટે
કંઈક એક્રેડિટેશન રિલેટેડ બોલો.
અચ્છા